All right, lesson 11, day 3 is going to take the things that we talked about with solving equations for missing side lengths and answer maybe a lingering question that if you were paying attention, you probably started to get. What if I don't know the angles? What if I know all the side lengths, but I don't know the angles? How do I find that information? And so that's why day 3, solving for missing angles, is the focus. And by the way, if you didn't have that thought like, we've been solving for sides all the time, must be nice. But what if we don't know the angles, and how do we do that then? You might want to start rethinking your life as a person who needs to study math and do well for the smarter balance and just better in life. Because that's kind of one of those like contemplative questions you should have when it comes to learning new information. The whatabouts is really important. So in our problem, we'll still use our 3 steps. We'll still look for step 1, label, then list, and then fill in the blank. Those are the 3 steps that we've been using for all of lesson 11, lesson 10 as well, and it doesn't go away. The label and list start to blend so that you can just do one or the other, or even to where they're not even necessary anymore, and you can just jump straight to fill in the blank. And so if you're a step 3 person already, awesome, go for it. I'm going to continue showing steps 1 and 2 to drive those skill points home, but ultimately, we don't need to do steps 1 and 2. We just need to jump straight to fill in the blank. Here we go. Step 1, label. Step 2, out of order. O equals 35. A equals 65. Okay, so in this information, there's no number that's given for h. I could find it. I could use Pythagorean theorem and get it. So, it's really 65 squared plus 35 squared square root. And I'm using Pythagorean theorem, but it doesn't matter. The point is, label, list, notice that OA are the 2 things that we know, which is a tangent relationship. So the tangent of theta is opposite over adjacent. And really, that would be an equation. We're running into a problem. Tangent theta needs to be the same as 35 over 65. And if I can get a little bit ahead of the game, 35 over 65 is approximately 0.5384. 5. Got to round correctly. So I could start by going tangent of 1. Nope. Oh, alarm. Tangent of 20. Nope, but it's closer. Tangent of 35. And it's somewhere between tangent 20 and tangent 35. So theta is between 20 and 35. And we can continue using the calculator to guess 30. 30 is really close. 30 is 577, so 30. Tangent 25. Really, I'm just guessing and checking. That's closer. So somewhere between 25 and 30 is the actual answer. Maybe it's a decimal value or it's really close. But the point is that whatever number we put into the tangent function, we better get this decimal back because this decimal is this fraction. That's the math for the day. Let's talk some notes. Go down to the next page. Or not the next page, it's going further down the page. Discussion 1. The intratask is a new type of trigonometry problem. These are problems that cannot be solved with just sine, cosine, or tangent. I'm going to put a just right there. Up until now, using algebraic properties helped us solve for the missing variable. We just can't divide tangent from each side. Notice that this is not a times. This is something you'll learn about more next year, like function f of x. Maybe I shouldn't talk about that yet. But the point is, it's not a multiplication problem. In order to help us deal with sine, cosine, and tangent, they need to have opposites or undoing operations. We need to have inverse trig functions. I mean, we already know about inverse operations, addition and, well done those of you who are like saying the answer out loud or at least thinking it loudly in your brain. Addition and subtraction are inverse operations. Now the rest of you join in. Multiplication and division are inverse operations. Trig functions work the same way. inverse trig functions do the opposite of regular trig functions. Like if you have sine theta and its opposite over hypotenuse, then let's put the sine on the other side of the equation. But let's use a little -1, like an exponent. Note, this is not specifically an exponent. Some guy, I think his name is Euler, E-U-L-E-R, came up with the idea of the notation being written this way. So sine inverse is opposite over hypotenuse. No, notice that this time the fraction goes in the parentheses, and the answer that gets spit out is the angle value. Star this box. This might be necessary for me to talk about when I'm back in classroom or after we're done looking at the lesson. This is an important box though, and really what I want you to understand is sine theta and sine inverse of the fraction. But there are parallels between the two. Let's go to the next page and let's actually solve the problem. Here in the entry task, we had come up with tangent, I guess we use theta, not L, but we came up with tangent of theta equals 35 over 65. So notice what's happening right here. If you do tan inverse on tangent, they cancel. And what's left inside is all that remains. But if you do tan inverse to the left side of the equation, you got to do tan inverse to the right side of the equation. And you can literally plug this in your calculator. I mean, I'm telling you the answer is approximately 28.3, but go to your calculator, plug it in, bum. When you press the trig button, there's an entire row of inverse operations. Just go over to tan to the -1 power. Tan to the -1 power, but we say tangent inverse or inverse tangent, and plug in 35 over 65. Oh dang, it's 28.3008 degrees. So we can get even more accurate than the example there. We still will use the same 3 initial steps. Step 1, label. Step 2, list. And then fill in the blank. This is an AH, so that's cosine. You might not have caught it, but I've intentionally got a gap between the equal sign and the 13 over 20. Because the math that's happening up here is the math that we use to make cosine go away. How do you make cosine go away? To get a by itself, you can't divide, you can't multiply, you can't add, you can't subtract it. It's bound through something called function. So we're going to use inverse. That makes those cancel, leaving a all by itself. And this makes cosine inverse the answer that we plug into the calculator. Cosine inverse, trig, cosine inverse, 13 over 20. I get to the nearest degree. I get 49. I'm going to give decimals, so I'm kind of like blanking on this rule right there, but I get 49.5 degrees. That's my answer for A. All right, I'm going to work entirely through B and C without talking about it, and then I'll come back and then say what it was that I did. Okay, so I wanted to work it all the way out for at least these two other ones. And let's go back to B. One of the things that I did differently in B is, well, okay, step one. I labeled, I listed, I recognized that it was a sine because OH were the two numbers that we knew. So I filled in the blank. Sine of theta is opposite over hypotenuse. And then, I didn't show it, but I'll show it now in talking to you. Technically, this is being written every time and it cancels out. Every time and it cancels out. And we're left, oh, do the other side. Oh, tucking this part into, this is garbage. This way I wrote it is just garbage. So I tried to clean it up this way. Plug it in the calculator, 72.2. Remember, you're in degree mode. In step C, I'm going to try to start doing steps 1 and 2 less and less and less. In this one, by doing less and less and less, I'm not going to make a list. I just know that I labeled. H doesn't have a number, so I can't use sine or cosine. It has to be a tangent. So tangent of C equals 14 over 29, opposite over adjacent. And then if I have tangent C, this is the math that's happening. The tangents are canceling because I'm using tangent inverse. And so when I plug inverse tangent, when I plug inverse tangent of 14 over 29 into the calculator, I get 25.8. For letter D, D is tricky, but you have all three numbers known. So you can use sine, cosine, inverse sine, inverse cosine, or inverse tangent. Sine inverse theta, HOA, of 68 over 85. Let's see what I get. $53.1. Cosine inverse of AH, 51 over 85. Oh my goodness. Tangent inverse of opposite over adjacent, 68 over 51. Holy smokes. I guess I really firmly believe that no matter which pair of sides I choose, as long as I'm choosing the correct OH, AH, OA, Oprah has a huge old apple that Afro's better. Oprah has a huge old afro that the ratios of the sides used with their inverse trig will all give you the same angle measure. You need to do E for homework and F for homework. Let's go to the next page. You need to do G for homework and H for homework. All right. Put a giant fantastic star on A. This one is so giant and fantastic for application, part 4, that it might even be a test question. Let's do it. Dan was walking through a forest when he came upon a sizable tree. He estimated he was about 40 meters away from the tree when he measured the angle of circle this word, angle of elevation. I have a demo for that for you tomorrow. Between the horizontal line and the top of the tree to be, this should be horizon, and the top of the tree to be 35 degrees. If Dan is about 2 meters tall, how tall is the tree? So 2 meters right there. What I'm doing is I'm labeling, but before I'm labeling, I'm setting up my scenario. I know that this is 40, and I need to know the height of the tree. Now I'm going to label. Theta, H, O, A, height. Okay, so list. Theta equals 35. H equals, we don't know. O equals the height that we're trying to find. And A equals 40. What about the 2, you ask, huh? Because you're the what about person thinking about things ahead of time. Good job. The 2 will be used at the very, very end, and I'll show you how. But because we know OA, fill in the blank. O over A, so it would be H of HT, height over 40. So multiply by 40 to get h by itself. Calculator work, 40 times tangent of 35, which is 28. And some change, but it's really close to just straight up 28. So the tree right here, this section of the tree is 28 meters. And then add the 2 meters where Dan's eye level looks up to see the top of the tree. And so really the height of the total tree is 30 meters tall. Let's keep going. Part B. Dan was pretty impressed, but then he turned around and he saw a bigger one, also 40 meters away. 40 meters. But in the other direction, wow, he said, I bet that tree is at least 50 meters tall. But then he thought for a moment, if this tree actually is 50 meters tall, well, I wonder what angle of elevation I would measure from my eye level to the top of the tree. Well, we need to find that angle. And by the way, if the tree is 50 meters tall, this segment right here is not part of the triangle that we're using. So don't get caught in the trap. Think about the smartness of this problem. You're looking for 48 and 40 to be side lengths that we compare. Okay, step 1, label, list. Okay, once again, it's a tangent because we know we have OA. But because we don't know the angle, tan inverse. I just jumped right to it. I didn't show the middle step of the fill in the blank. Maybe the fill in the blank is actually related to that table back on the very first page. If you need to know the angle, but you know the opposite and adjacent sides, use tan inverse. And so, I mean, it's on the wrong side relative to this problem, but using what we did on the first page of this day 3 lesson, theta is tan inverse 48 over 40. Go to the calculator, plug it in. Tan inverse 48 over 40. And I get theta equals 50.2. So this is a 50.2 degree angle. After this lesson is done, or after we finish talking about it, you really should have all of the access you need to understanding triangles, how to find the measure of missing sides in triangles, because we have several ways of doing this. Okay? In the same way that mathematicians have named certain ratios within right triangles, they've also developed terminology. So given the ratio of the sides, we use the prefix arc because an angle is not just measured as an angle, but it's also an arc on the circle. This might be a radian. Anyway, not a word for you to know right now. We'll talk about radian measure when we get to algebra 2. But we might use arc sine instead of sine inverse. We might say arc cosine instead of cosine inverse, and arc tangent instead of tan inverse. These are the exact same things. It's just terminology that one mathematician might use at algebra 2 and terminology that a mathematician might use for geometry, but they do the same work. And in your calculator, this is just easier to put into a button. Okay, we'll do the exit ticket, and then you need to be done. Make sure that you do the closing, you review the learning target and success criteria. I can write and solve trig equations for solve for a missing angle. Extra practice, practice with the homework. Here it is, exit ticket. Shelves are being built in a classroom to hold textbooks. So shelf. The shelves will extend 10 inches from the wall, so 10. Support braces will need to be installed to secure the shelves. The braces will be attached to the end of the shelf. No, here. And secured 6 inches below the wall. So 6. What angle, with what angle measure will the brace and the shelf, so that's X that they've defined right here, make? Step 1. Step 2. OA are known. A lot of tangent problems on this one. I'm sorry. We'll try for some more originality. However, this will do the problem. O over A. Plug it in. Tan inverse 6 over 10. And I get 30.96 degrees, or 31 degrees. As in, this is a 31-degree angle. All right, that's the lesson for the day. And we'll talk lesson 12 tomorrow, but make sure you get your homework done. The homework is the problem sets for both of these days. The problem set for day 3, problem set for day 2. And you know what? You should have done the problem set from day 1 from the other day too. Bye. See you on Friday.